The upcoming announcement of the iPhone 18 Pro and iPhone 18 Pro Max, anticipated in early September, brings an impressive suite of 12 distinct hardware and technological upgrades. As mobile technology reaches new levels of performance and hardware integration, these rumored changes highlight Apple's ongoing shift toward complete in-house silicon design, optical engineering, and battery efficiency. Examining each of these upgrades provides a thorough perspective on what consumers can expect from this flagship generation. The first notable change centers on physical ergonomics and device dimensions. The iPhone 18 Pro and Pro Max are expected to undergo a subtle increase in overall chassis thickness, expanding by approximately 0.1 to 0.2 mm compared to their predecessors. While a difference of this size is virtually imperceptible to the human hand, equivalent roughly to the thickness of a fingernail or a sheet of paper, it plays a significant role in internal hardware layout. This minor dimensional expansion means existing cases designed for the iPhone 17 Pro series will not fit the new models. More importantly, the extra internal depth provides the precise volume needed to house larger battery cells, updated thermal systems, and advanced optical components. Accompanying this structural adjustment is an overhaul of the external color offerings. Apple is expanding its palette to 4 distinct finishes for the Pro lineup. Alongside the retained silver finish, the series will introduce a rich dark cherry tone, a refreshed space black, and a lighter Sierra blue variant. The return of a true space black option answers long-standing requests from users seeking a deeper matte finish on titanium frames. Meanwhile, colors like dark cherry and Sierra blue provide distinct visual identities, giving consumers a broader range of premium aesthetic choices. The third design refinement focuses on the back glass assembly. On previous models, a noticeable contrast existed between the matte finish of the rear plate and the glossy housing of the camera plateau. For the iPhone 18 Pro series, Apple has unified the back glass manufacturing process, applying a consistent, single-tone finish across the entire rear surface. This eliminates the dual-tone effect and creates a seamless visual flow. Rumors also point to testing around subtle rear glass translucency, potentially offering faint glimpses of internal components under direct lighting, though the primary shift remains the harmonized single-tone rear panel. Internal space gained from the slightly thicker frame directly enables the fourth key upgrade, a physical battery capacity expansion. In particular, ESIM variants are expected to feature a battery capacity increase of around 10%. In modern smartphone engineering, gaining 10% raw capacity represents a major operational leap. When combined with power optimizations across the processor and display, this hardware upgrade delivers noticeable extensions in overall device runtime during heavy workloads, media playback, and daily navigation. Powering these features is the fifth major upgrade, the next-generation A20 Pro chipset. Departing from iterative improvements, the A20 Pro is built on TSMC's 2nm manufacturing process. Transitioning from 3nm to 2nm architecture allows billions of additional transistors to be integrated into a compact space, drastically reducing electrical power consumption and current leakage. This architecture chip alone is projected to yield up to a 20% improvement in energy efficiency, allowing demanding AI processing, graphics rendering, and computational tasks to run smoothly without draining the battery. The sixth upgrade marks a major step in Apple's communication strategy with the introduction of the custom-designed C2 modem chip. Designed in-house to replace third-party basebands in select global markets such as Europe and China, the C2 chip integrates directly into Apple's unified system architecture. This deep integration reduces power draw during cellular data transfers. In regional markets where physical SIM trays are retained alongside smaller internal battery spaces, the efficiency of the C2 modem helps offset battery size differences, matching performance with eSIM-only models. Building on custom connectivity, the seventh upgrade expands satellite communication beyond emergency messaging into broader data usage. Users will be able to access low-bandwidth internet connectivity via satellite in off-grid environments, enabling web browsing, audio streaming, and low-resolution video playback up to 720p. Upgraded radio frequency modules and dynamic beamforming allow the device to lock onto satellite networks directly without requiring heavy external antennas. Complementing cellular and satellite developments, The 8th upgrade brings the N2, Network 2, wireless chip. Operating as an update to the N1 wireless controller, the N2 chip focuses on lowering latency and maximizing power efficiency across Wi-Fi and Bluetooth protocols. By handling local device communication and short-range wireless tasks with minimal energy consumption, the N2 chip further reduces overall system thermal output and conserves battery life. The 9th leak focuses on display technology through the adoption of LTPO plus OLED panels. These next-generation screens incorporate advanced anti-reflective surface coatings, significantly reducing glare under direct sunlight or intense ambient light. By minimizing environmental reflections, users can view content clearly without needing to maximize manual screen brightness, which preserves power. The LTPO Plus technology also enables smoother dynamic refresh rate scaling, improving efficiency when displaying static content or the always-on screen. Front-facing aesthetics and functionality receive an upgrade in the 10th leak, which describes a reduced dynamic island. By miniaturizing Face ID hardware components and shifting elements like the flood illuminator beneath the display, Apple has reduced the overall footprint of the dynamic island cutout by approximately 1/3. This reduction increases usable display real estate for videos, games, and applications while preserving facial recognition security. The 11th upgrade introduces a mechanical variable aperture to the primary rear camera. Unlike fixed aperture camera systems that rely on digital algorithms to simulate background blur, a variable aperture uses physical iris blades to control the light reaching the sensor. The lens opens wide in low-light environments to maximize light capture and steps down in bright lighting or close-up shots to expand the natural depth of field. This mechanical system gives photographers and videographers precise optical control over exposure and natural background bokeh. Finally, the 12th upgrade addresses the camera control button through a simplified and cost-optimized mechanical redesign. Previous implementations faced criticism due to complex capacitive sensor arrangements that were costly to repair if damaged. The updated camera control button uses a streamlined pressure-sensitive mechanism that improves tactile click response while lowering replacement expenses. Together, these 12 leaks depict a comprehensive generational leap for the iPhone 18 Pro and Pro Max, combining custom hardware engineering, enhanced optics, and substantial battery improvements into a refined flagship package.